Summary of coordinate geometry. So coordinate geometry is a special question. It's a special subject, special topic. It makes an appearance in almost, if not all, ZIMSEC papers. It's one of the pillar topics, but it is lighter as compared to other topics. So what exactly is it about? Chekutanga, you have a point in space like this, and just a point. We want to know what that point is. Saka kuti tigone ku identify the position of a point in space, we need a reference point. And reference point ndeyekuti, for example, kuti muone kuti chinhu chiri kufamba, for example, and because kana mukaona kuti uyo munhu ari kuuya kunoku zvoreva kuti muri kugona, muri kuidentify the change in position of that person as that person approaches you, but you need a relative, you need a reference point. And like, how do you know that something is moving if you cannot compare it to anything? You cannot. We need a reference point. So if we simply have a point in space and we want to know the position of that point, there was a mathematician by the name Cartesian who theorized that we can actually have this plane. It's called the XY plane. And it saka X inoi do the horizontal axis and Y iriyochi the vertical axis. Okay. Saka kuti tizive the position of this point, convention kana kuti nzira yatinoshandisa ndeyekuti we firstly need to know its position relative to the horizontal axis. Saka toda kutanga taziva kuti x axis value yacho angarichi, we can say in the 3. Then tozoziva kuti ko y value yacho angarichi, panapa we can say in the 2. Saka the position of this point, call it A, will be 3, 4. 3, 2, sorry. So this is how we name positions. A, X, Y. Murukubabata. Okay. Let us now say we have the same situation. This is Y, X, but now we do have 2 points, A and B. And it. Then we say we have a line connecting 2 points. Saka tichisina just a point, tavane a line. Saka we know what this position is, and we also know what the position of B is. Saka let us say kuti A tatora uyo ndi 3, 2. Let us say kuti B ndi 4 kana kuti 6 to make it more realistic, ndi 6, 3, like that. We now have a line. Saka this line, how are we going to define it? Kuti tite define a line, we need what they call an equation of the line. And the equation of the line, the general statement is y is equal to mx plus c. Kana tichiti x and y, this is simply a point, kana kuti points. And it x iri kurepresenta ma x coordinates. Tatsina yedu kuzvitaura panapa kuti this is called an x coordinate, saka ichinzi coordinate geometry. This is called a y coordinate. Anditika? Saka x and y, this is just a point or points. Then m inoi iri kurepresenta what is referred to as a gradient. Mathematical literature sometimes calls this a slope. And I'm going to discuss what it is. Then c iri kurepresenta what we refer to as a y-intercept. That is what c is. Saka kantange na c because it's easier. Kana tichiti y-intercept tiri kuti this is the point where our line crosses the y-axis. Saka point inoi ndo inonzi y-intercept c. Line redu parino cheka y-axis ndipo pa c. And we are going to take note kuti line redu parino cheka y-axis value ya x ananga ari 0. Kora kuti c as a point inenge ichiti c inenge ichiti 0 c. 0 x coordinate, c y coordinate. Mrupa bata. Okay. Let us now discuss gradient. We are going to have one or two examples. This is a summary. It's not exhaustive. It's a summary. Gradient. Vamwe vanoti slope. Kana muchiita this, especially ku physics, it's called an inclination. And I think this is a special word, but maths never expect this. It's always gradient or slope, but usually gradient. What happens is we are still looking at the line. But now if we have a horizontal line, and it horizontal line, this is what mathematicians have decided to refer to as the reference point. Kana kuti the starting point. And the reference point, the starting point. Here gradient is equal to 0. Saka kuti to understand what we are referring to, let us still have our xy plane. And when you begin to do, if you are doing mathematics at a higher level, you should know that this changes a little. This is just for your interest. It becomes three-dimensional like this. It becomes x, y, z. It's now more realistic. This is two-dimensional, it's simplistic, oversimplified. But panapa, if we say we have a point, so that our point, zvakafanana nekuva ne point mukati me box. And the box has 3 dimensions, length, width and height. And but this is essential for your learning. We never do 3 dimensions. We only end at 2 at O level. But it's important to know that it goes beyond that. And then let us say we still have A and B. We still want to define this line. But in order for us to be able to define this line, we want to know kuti line iri slope, imagine mukwidza kana mudzisirwa. And imagine kuti this line is a flat ground. Flat. And then you can have mukwidza. Samugona kuti mukwidza unenge uri, we can in physics we actually calculate this angle theta. But mukwidza unenge uri at an angle from the horizontal. In mathematics we don't calculate the angle, we calculate something else. But what I'm just trying to bring to your attention is we are literally comparing this, how the slantedness, a measure of how slanted a line is, to its horizontal like this. Anditika. Okay. Saka, this is what gradient is. It's a measure of how slanted a line is. Okay. So in mathematics, we are not going to look at the science, the physics part of it, but in mathematics, we define gradient as a change in y over a change in x. And when you now look at science and other subjects which really apply this, vanenge vakuti change in y and change in y relative to a unit change in x. But let us not look at it like that. Let us just say change in y over change in x. But to be more safer, let us write it in word form. Gradient is change in y over change in x. Ichi triangle ichi I capital letter ya D kana tiri Greek alphabet. Greek alphabet, the first letter and the alpha, the last letter and the omega. And it. So when we say Jesus is the alpha and the omega, we are simply saying Jesus is A and Z. Then the letter D in saka it's alpha, beta, and so forth, gamma, shingoenda. I once knew it, I no longer know it. Saka the letter D is called delta. It's written like this. In those small letter, this is the capital letter. Saka kuti delta, we are just honoring where it came from. Those no direct change in delta y over delta x, change in y over change in x. But what you are going to see when we begin to do questions, what I really want you to know is gradient is equal to y2 minus y1 over x2 minus x1. What's happening? We are going to define these two endpoints. We can use any 2 points on a line to find the gradient of a line, especially if it is straight. But we usually prefer to use endpoints. Saka tikati b tikamdefine as x2 y2, a tomdefine as x1 y1. Saka y2 minus y1 ndiyo change in y. Chiri kunzi change in y ndepanapa kuchinja kuri pano kubva from this imaginary line kusvikira panapa, kusimuka kwaita line redu in the vertical sense. Babata. Then change in x, it's now some describing the effect of the change in terms of the horizontal. Saka, this is how I want you to do it. Then other facts which we are going to be dealing with, pachatanga tama questions, anoti number 1, the gradient of a straight line is constant. And itika kuti constant zoreva kuti does not change. Number 2, ndeyekuti the gradient or the gradients of parallel lines are equal. Parallel lines are lines which never meet. you should know kuti line rino iri neline iri are not parallel, even though they are not physically meeting panapa, but if we produce it like this, tikawedzera kurebesa this line towedzera kurebesa that line, they are eventually going to meet somewhere. Saka kana chiti parallel lines kurama line which never meet, so never is the important word. Andidka? Okay. Then the other thing is, remember I told you kuti kana line re horizontal, a straight line, gradient ndi 0. Ko kana line re vertical, gradient is infinite. And this is the symbol of infinite, but core level you're allowed to say it's not applicable like this. And there are reasons, there are mathematical reasons to substantiate this. Because panapa, remember, let me just steer your understanding. Antitati gradient is equal to y2 minus y1 over x2 minus x1. Samakatarisa pa line re horizontal, mchaona kuti the x is changing. This is the change in x. And x2 minus x1. But y is not changing. Y is 0. Correct gradient panapa it's 0 over a change in x. That's why it's 0. But zvirukuitika panapa ndezvekuti y is changing. y2 minus y1. Saka there's a change in y, but x is not changing. It's 0. And we should know by now that when you divide by 0, you get, can I calculate not error 2? You get infinite, you don't get an answer. Saka this is important. Saka I am a reasons they are not material, but they are just there to steer your interest. You should know kuti kana line rakadai so uri mukwidza, our gradient is greater than 0, kureva kuti our gradient is positive. Kana line rakadai so uri mudzisirwa, our gradient is less than 0, kureva kuti our gradient is negative. And then you should know y is equals to mx plus c. Saka I don't expect you to kuti ndakuudzai zvimotoenda motonoweka maquestions acho muchimagona and stuff. That's not how math is learned, but this was just an introduction. Are there questions before we bring in questions?